Tell me, ma. Unmute yourself. Tell me. Here also yesterday I have drawn one path. So A to G. Suppose if you are moving the block, so in the video also you can see that the block of mass, the block of some mass is being applied with some force. Okay, with some force. Here you can move the block whether in this direction, or you can move the block whether in this direction, or you can move from directly A to B. It does not matter. Okay. So which path you are following, it does not matter. It matters what is your initial position, what is your initial position, and what is your final position. Initial position and final position. Okay. So this is called conservative force. Conservative force. So what is a conservative force? A force is said to be conservative if the work done by the force on a particle moves through any round trip is zero. Any round trip is zero. So if you take from here to here or from here to here, okay. So in a round trip, the work done should be zero. So this is what I explained in the last class. And also, it does not depend on the path taken. It does not depend on the path taken, but it depends on initial and final positions of the path. Okay. Now, example for conservative force. So, the best example for conservative force, we can take it as a gravitational force. Gravitational force. Okay. See, to this block of mass 5 kg, what will be the weight? What will be the weight of this block? So weight means we know, weight means mass into gravity. So mass is 5 kg into g. At what acceleration this block is being attracted by the earth? We know that it is 9.8 meters per second square. Okay. Now if you multiply 5 into 9.8, we got here 49 Newton. So this is the weight of this block. Okay. Now when you move this block up or whether it is moving down, suppose let us say if you are moving this block downward direction, 6 meters downward direction, what will be the work done? We know work done means force into displacement. Here force is what force here? Gravitational force. That is 49 into displacement is 6 meters. So 49 into 6, we got it here, it has around 294 joules. So this is the work done by the block when the block is taken from one point to another point of 6 meters. Okay. Now let us see when it moved to upward direction, what will be the force? Okay. So for downward, we got it as plus 294 joules. Okay. So work done by first downward trip. Work done by downward trip is how much here? 294 joules. Why we have taken plus here means because the force is along the direction of displacement is along the direction of applied force. Okay. So displacement is along the direction of applied force. So we have taken here plus. Suppose if the displacement is opposite to the direction of applied force, then we have to take it as negative. Okay. Yes. See here. Now when the block is moved upward direction, but force of gravity is acting downward direction. Okay. So in that case, work done on upward trip is minus 294. Minus 294. Okay. Again, if you move it downward, what is the work done? Plus 294. Okay. If you see here, plus 294 minus 294. If you add these two, what we get here? Work done we get it as a 0. Work done will get it as a 0. So that's why we are calling it as in a round trip, the work done by a force is 0, then the force is conservative force. Okay. Any doubt here? Bharti ma'am, any doubt?
Yeah, 1 second, sir.
Mukta?
Sir, can for
Yeah, sorry.